term deductive reasoning is when you use facts, rules, or definitions to reach logical conclusions. And the rules that we're going to use are called the Law of Detachment and the Law of Syllogism. The first logic law we're going to focus on is the Law of Detachment. We're going to define the Law of Detachment, and then we're going to work some examples here, and then we'll move over to the right side of our notes. The Law of Detachment is to say, you're going to have your conditional statement, if P then Q, and that will be given to you. If this is a true statement, then they tell you something else about your original hypothesis P. Your conclusion is going to be that Q is also true. And those three little dots there means your conclusion. Okay, so what we're going to do is for each conditional statement we label what our hypothesis is and what our conclusion is. And then the next statement we identify it as our hypothesis or our conclusion, or if it's neither, we give it a new title. And you'll see that here in the first example. So if you are in Alaska follows the if, so that's our hypothesis. Then there is no billboard advertising because it is banned. So there is no billboard advertising would be our Q. Remember, your conditional statement is always P arrow Q, if P then Q. Okay, now we're given a new piece of information. It says that Teresa is in Anchorage. Well, originally we were told that if you are in Alaska is our hypothesis. Well, Anchorage is also in Alaska. So what we've done here is we referred to our hypothesis because Anchorage refers to being in Alaska. So far we have P arrow Q, we have our hypothesis, it's been restated in another way, and we can conclude that Q is true. So we can conclude, as it refers to Teresa, that Teresa will see no billboard advertising. So that refers to our Q, our conclusion. The next example is one where we will not be able to reach a conclusion because it doesn't follow the logic law. So as always, we start with labeling our P and our Q. If a pet is a dog, that would be P, where a pet is a dog. It chases squirrels, that would be our Q. So we have if P, then Q. Next sentence we're given, my pet chases squirrels. Well, chasing squirrels refers to our conclusion. If you look back at our logic law for Law of Detachment, it said we had to have P then Q, and then we'd have to refer to P again. Well, here we have P then Q, and they refer to Q. So because it doesn't say P then Q, P, we can't reach a conclusion because it doesn't follow the Law of Detachment. So no conclusion can be made about this pet that chases squirrels. And the reason being is you can have any other pet, a cat that chases squirrels. So just because the pet chases squirrels doesn't necessarily mean that it is a dog. It could be a cat. So that's why we cannot reach a conclusion. All right, I'd like for you to try example 3. And we're going to determine whether the conclusion is valid based on the information. So just label P then Q here, and then determine if this is the hypothesis or conclusion. And we'll come together and decide if the conclusion is valid. So we said that if a cow is brown, that's our hypothesis. It produces chocolate milk, that's our conclusion. And then the next statement we said Daisy is a brown cow. So that refers to our cow who is brown. Daisy is a brown cow. That's referring to our hypothesis. Our conclusion says that because Daisy is a brown cow, Daisy produces chocolate milk. And that directly is referring to the conclusion produces chocolate milk. So we have a Q, which is true. So because this follows P then Q, given P, conclusion Q, the conclusion is true based on the law of detachment. Okay, so I would like for you to pause the video and try number 4 on your own, completely from the start to finish, determining whether or not the conclusion is true. Okay, so on example 4, you should have had P then Q, given P, because 20 is a number that is divisible by 10, and Q is also true because 20 is the same number divisible by 5. If you had trouble with this, raise your hand or ask a neighbor. Alright, and I'd like for you to try example number 5 on your own. Pause the video and then determine whether or not the conclusion is true or false based on the law of detachment. Okay, so you should have said that the conclusion is false because this P then Q given Q does not follow the law of detachment. If it followed the law of detachment, we would have had a reference to P first before we reference Q. Raise your hand if you need help with that one as well. Okay, now we will focus on the law of syllogism, and this one you'll be given the conditional statement P then Q, and then you're also going to be given another conditional statement Q then R. Based on that, your conclusion will be to cross out the Q's, so you'd cross out the Q's, and you would be left with P then R. So you will see that worked in example 1. So first we identify P and Q in each conditional statement. If the groundhog sees his shadow, so anytime the groundhog sees his shadow, that's P, he will go back into his burrow. Anytime the groundhog goes back into his burrow, that's Q. If the groundhog goes back into his burrow, well, we've already talked about the groundhog going back into his burrow. We said anytime we talked about that, it was Q. Then he will have 6 more weeks of winter. Well, because we've been given some piece of information that we have not referred to before, we call it R. And that's just a way to identify it as something different than P and Q, because we haven't talked about 6 more weeks of winter yet. We give it a new title, R. So far we've followed the law of syllogism, P then Q, Q then R. So based on the law of syllogism, we cross out the Q's and we're left with P then R. So my conclusion would be P, if the groundhog sees his shadow, then R. Then we will have 6 more weeks of winter. Okay, so following the law of syllogism, I'd like for you to try example 2 on your own, and then I'll unpause the video to see if you get what I get. So from start to finish, this is what the answer should be. And your conclusion should be written as, if it is Tuesday, then Daryl drinks a latte from Starbucks. If you did not get this, please raise your hand. And sometimes you won't be asked to determine what the conclusion is. Sometimes you're just going to be asked if the conclusion is true or false. So all we have to do is look to see if it follows the pattern of P then Q, Q then R, conclude P then R. So for example 3, if it snows today, anytime we talk about snowing today, it's going to be a P. And I will wear my wool socks. Anytime we refer to wearing wool socks, that's a Q. Then we talk about if I wear my wool socks in the next sentence. Well, that was Q. Then my feet will itch. And feet itching is something that we haven't talked about before, so we give it a new letter, letter R. So based on this, my conclusion should be, if it snows today, then my feet will itch, because the Q's get crossed out. So I look at the conclusion they gave us. If it snows today, that's P, then my feet will itch. That's R. So, because it follows the law of syllogism, this is a true conclusion. Okay, now I'd like for you to pause the video and determine if the conclusion here is true or false. Okay, and because number 4 does not follow the law of syllogism, we say that it is a false conclusion. If you had trouble identifying P's, Q's, and R's, please raise your hand or ask a neighbor. And finally, go ahead and try number 5. Pause the video to see if you get what I get. Determine whether or not the conclusion is true or false, based on the law of syllogism. And we would say that this is a true conclusion based on the law of syllogism. So now we're going to mix up the 2 logic laws, and you're going to have to determine whether the law is detachment or syllogism. So for example 1, break down whether it's hypothesis conclusion, so P then Q, and identify the symbolic form, and then determine which law, if any, number 1 follows. Pause the video to see if you get what I get. So if we follow the sequence, you break an item in a store, that's P, then you must pay for it, that's Q. Jill broke a vase in Potter's gift shop. Jill breaking a vase in Potter's gift shop is referring to someone breaking an item in a store. So yes, we've introduced a person's name, we've introduced an object, breaking a vase, and we've introduced a different type of store, a gift shop. All of that is relating to breaking an item in a store. So that's our hypothesis. Jill must pay for the vase. Well, because she broke an item in a store, the conclusion is that she must pay for it. So Jill must pay for the vase. Now that we've followed P then Q, given P, conclude Q, the logic law that we've used is the law of detachment. So now I'd like for you to try number 2 to identify your P's, Q's, and R's and determine whether or not the law of syllogism or detachment has been used. If none has been used, then say it's not a valid conclusion. If this is not the answer that you got, please raise your hand or ask a neighbor. Okay, for the next example, number 3, I'd like for you to try it out on your own, but just take note that this means measure of angle A. So pause the video and determine if a logic law has been used to reach a valid conclusion, and see if you get what I get. Okay, in your symbolic form, make sure that you remember to put the symbol here, the tilde, which represents the opposite of your conclusion. If you didn't have this or any form of this, please raise your hand, and we'll work on the next example, number 4. Pause the video to see if you get what I get. Alright, if that's not what you got, let me know or ask a neighbor. We'll move on to example number 5. So now we're also going to do the same thing. This is very repetitive, but more practice makes perfect. We're going to identify if it's possible to write a conclusion, and then if so, state the law of logic that we used. So if someone has raced the Indianapolis 500, that's going to be our P. Then he or she is a professional racer. That's going to be our Q. Bobby Raoul, that's someone, has raced an Indianapolis 500. That's someone racing the Indianapolis 500. So we've referred to our P again. So because we've gone P then Q, next statement P, we can conclude based on the law of detachment that Q is true. So the law of detachment says to take our Q as it relates to Bobby Raoul, that we can determine he is a professional racer. Okay, example number 6. Rewrite the following deductive argument using symbols. Then use the law of detachment to tell whether the reasoning is valid. Is the conclusion valid? So we start off with, if you drive more than 65 miles per hour, that's our hypothesis, you will always get a ticket. Then Q, our conclusion. Joe got a ticket. Well, Joe isn't a new thing, isn't an R, isn't a new idea, but someone getting a ticket refers to our Q. The law of detachment, remember, says P then Q given P. And since we don't have that exact order, we can say that the conclusion is not valid. And what they say is, therefore, that's conclusion, Joe drove over 65 miles per hour. And that refers to our hypothesis again, driving over more than 65 miles per hour, which is not valid because it does not follow the law of detachment. Okay, and last example, I'd like for you to try number 7. Pause the video to see if you get the same answer I do. Number 7 is E, we cannot determine, because we have if Brandon is an athlete and he gets paid, that will be our P, Brandon being an athlete and getting paid. Then he is a professional athlete, that's our Q. And the first statement you have, the first conditional statement you have, that's always going to be P then Q. Everything else follows from that original P then Q. Then we say that Brandon plays football. Well, Brandon playing football has not been referenced either here or here in the hypothesis or the conclusion. So we can call that R because we haven't talked about Brandon playing football yet. Well, because we don't have a logic law, P then Q R doesn't follow syllogism or detachment, no conclusion can be determined based on what we've been given.